In this lesson, we are going to talk about the energy transformation and energy transfer. Here are the main contents: forms of energy, energy conversion, conservation of energy, and energy calculation. We will get right into forms of energy. First of all is the kinetic energy. An object is moving has a kinetic energy, and we can say that the faster an object moves, the greater its KE. Rather, this because we need to transfer energy to get an object moving. Hence, more energy, the faster the object moves. Next is the gravitational potential energy. If you lift an object upwards, then you are actually giving it GPE. The higher an object is above the ground, the greater its GPE. And also you can say that if an object falls, it can get the energy back again. Next is the chemical energy. Fuels such as coal or petrol, gasoline are stores of chemical energy. Fuel is a store of energy, so when it burns, the energy is released as the form of heat or light. Continue, we have electrical energy. It can be transferred in an electric current. Nuclear energy. All radioactive materials are stored of nuclear energy, and the example for this is uranium. The energy is stored in the nucleus of atom. Elastic energy. The energy is stored by an object that has been stretched or squashed in an elastic way. For instance, a rubber band or a spring. An object will spring back to its original dimension after all the force has removed. Internal energy. When you are heating up your food or your body, you are actually giving energy to the atoms. So you can say that the energy is stored in a hot object. Thermal energy or heat energy. You only need to know that this is the energy that travels from a hot object to a colder one. Light energy. If you heat something up very hot, then the object will glow brightly and give out light energy. So light radiates outwards or around the hot object. Lastly is the sound energy. Energy can be also transferred to an object surrounding as sound energy, and the easiest example for this is a speaker. So after knowing all forms of energy, we can summarize everything up by saying energy can be stored in an object, or it can be transferred from one object to another. Energy can be transferred by force when you are doing work to an object, by heating, radiation, or electricity. Here is a table for you to classify which is energy stored and which is energy transfer.
Next, in 6.2, we're going to talk about energy conversion. Energy can neither be created nor destroyed. It can only be transferred or changed from one form to another. For example, when launching a rocket, here's how energy is being transformed. We can also represent the conversion as an equation. Chemical energy turned to kinetic energy plus gravitational potential energy plus thermal energy, light energy, and sound energy.
The third part of this lesson is 6.3 Conservation of Energy. So what is the conservation of energy? When energy is transformed from one form to another, it's often the case that some of the energy ends up in a form that we don't want. For example, the energy transformations in a light bulb. The bulb produces light energy, which we do want, but also thermal heat energy, which we do not want. The rocket motor transforms chemical energy into two forms that we do want: kinetic energy and gravitational potential energy, and three that we don't want: heat, light, and sound energy. Next is the principle of conservation of energy. In any conversion, the total amount of energy before and after the conversion is constant. This tells us something very important about energy. Energy can neither be created nor destroyed. It can only be transferred or changed from one form to another. Energy efficiency. Most wasted energy ends up as thermal energy because when fuel are burned, they produce heat as an intermediate step. Friction is very often a problem when things are moving. Lubrication can help to reduce friction, and a streamlined design can reduce air resistance. Another common form of wasted energy is sound. It is important to make good use of energy resources available to us. Energy is expensive, supplies are often limited, and our use of energy can somehow damage the environment. So what's the definition of efficiency? The efficiency of an energy conversion, it's the fraction of the energy that ends up in the desired form. We use light bulbs to provide us with light. The picture shows two types of light bulb. The one on the left, it's a filament lamp, and the other one, it's a energy efficient lamp. The chart shows the energy they use each second. The diagram shows that each of the two bulbs produces the same amount of light energy. However, because it wastes much less energy as heat, the energy efficient lamp requires a much smaller input of electrical energy. Energy becoming dissipated. Energy changes are usually less than 100% efficient. Energy escapes and can be wasted as heat. This means that objects and their surroundings are warmed, and it's very difficult to get that energy back. That energy dissipated, spread out during an energy change. And we have some way to calculate the efficiency. We can calculate the percentage of efficiency of an energy change as follows. Efficiency equals useful energy output divided by energy input times 100.
6.4 is about energy calculation, and there are two energy calculation we are going to learn today, which is gravitational potential energy and kinetic energy. An object's gravitational potential energy depends on two factors: the object weight. The greater its weight, the greater its gravitational energy. And the second factor is height above the ground level. And the greater its height, the greater its gravitational energy. And the formula for gravitational potential energy is mass times acceleration due to gravity and times height. Next up is kinetic energy. The kinetic energy of an object depends on the object's mass and its speed. The formula for kinetic energy is 1/2 times mass times speed square. And that's the end of the presentation. Thank you for listening.